Let's start out with our study on common fractions. Up here on the board, we'll let this represent a bar, and I've got that bar cut into 4 pieces. A fraction, a common fraction, tells what part of the whole. Now I've got a fraction up here of 1/4. Now this is a proper fraction. It's reduced down to the lowest. My numerator is smaller than my denominator. This is a proper fraction. Now, like I say, this fraction tells what part of the whole. The denominator, the number on the bottom, represents the number of pieces that our whole is divided into, the number of equal pieces that it's divided into. The numerator, the number on top, represents the number of those pieces that are being considered. So actually we're considering this 1/4 then would represent one of those sections that we have divided up in our bar. Now, if I was to add fractions, let's say that I want to add 1/2 to this 1/4. In other words, let's say I've got over here another whole. Now, like I say, the denominator determines how many pieces that the whole is divided into. We're considering one of those pieces with the 1/2, so I'll shade that in. In other words, this is 1/2 of that whole. Now, you can see that if I wanted to add together this 1/2 and that 1/4, they aren't equal size, so I can't add them together without first changing the size of those particular segments. Now, the way I do that, if I want to add those two values together, what I have to do first is to make common denominators, make them divided into the same size segments. Then I can add them together. And I'm sure you've heard it many times where they would say, well, you can't add apples and oranges, and that's where this comes from. So what I have to do is make all of the same common denominator. Now, if I change this 1/2 to 4ths, I can multiply the same number on both sides and not change its value. However, I can change the size of the segments that I'm considering over here with my fractions. Now, if I want the same common denominator here, I'm going to have to multiply this particular fraction by 2. That way I'll have 4ths on the bottom. Now, to maintain the same value, I have to also multiply the 2 on the numerator. So I will bring this over. We have 1/4. Now I want to multiply 2 on both sides, both my numerator and my denominator, so that I would have 2/4. Now 2/4 is the same value as 1/2. However, I'm dividing into the same size segments so that I can add my fractions together. Now, what I'm doing actually over here, you see, I'm changing this 2/4, my whole into 2/4. Now you see I can add together my equal values that are being considered. Now to do that, what I do is I add together the numerators. I have 1, I have 2, 4, 3, and then bring down my 4ths. So if I was to add 1/4 and 1/2, my answer would be then 3/4. We just added fractions. Now, let me give you an application that you will use for that when you get into the second year of the program. In the second year of the program, we have a formula for figuring total resistance. R sub t now is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now, you aren't expected to have to use this formula at this time. However, you can see that on the bottom side of this formula, in other words, this is a fraction in itself, we have fractions under fractions. But you can see what we have to do here is we have to add the resistors. We make reciprocals out of the resistors, then we have to add those resistors together. And before we can do that, we have to have the same common denominator. Now, let's say that I have a number 5, and I have to make a reciprocal out of that. A reciprocal is when you take your number into 1. So that to make a reciprocal out of 5, I would have 1/5. If I have another resistor, now like I say, you aren't concerned about the application other than how to go about adding fraction. Now, if I had 10 as another number, make a reciprocal out of that, I'm taking 10 into 1. Another one, if I want to add it together, let's say that let's say I've got 30 as my other value. Make a reciprocal out of that 30, I take 30 into 1. Now, if I want to add all of those together, such as it shows in this formula, then I must find a common denominator to all 3 of those. Now, the common denominator for all 3 of them would be 30, so I'm going to change all of these to 30ths. Now, keeping in mind we're taking the whole and into 30, and we're considering how many parts of that whole. Now, if I want 30ths out of this fraction, I have to multiply 30 times the denominator. If I do it times the denominator, then I have to also to the numerator, so then I would have 6 30ths. Now, 6 30ths is equal to 1/5. In other words, if I would reduce this on down, I would have 1/5. You see, I can multiply the same number on either side and not change its value. I can divide by the same value on either side and not change its value. If I want to reduce that, I would have to divide the same number on either side. Now, down here, you see, I would have to take 3 times the 10 to get 30, so that means I have to take 3 times the 1 as well, then. So I've got 3 30ths. Down here, you see, I don't have to change this because this is same common denominator. Now, what I have to do here is to add together the numerators. In this case, you see, I've got 10. I'm adding these now. I would have 10, and bring down my denominator. Now, you see, I can reduce this on down. It's improper such as we see it. We want to reduce all our fractions on down. I can divide 10 into either side, which gives me 1 then over 3. So my answer for those particular fractions added together would be 1/3. If I had 1/5, 1/10, and 1/30th, I would have 1/3 for an answer. Okay. Now we're going to have to divide. You see, in other words, we're going to take this reciprocal into 1, which is finding the reciprocal of it again. When we get into division of fractions, we'll come back to that. Now let's add together some mixed fractions. Up here on the board, I've got your assignment sheet number 3, 1A problem. We're supposed to add together these two mixed numbers. Now, in other words, we've got mixed numbers here. We have whole numbers and fractions, and of course, like I say, these are mixed numbers. Now, what we want to do is make the same common denominator out of those two fractions. And of course, whenever in doubt, just multiply the two together, and you should be right. Multiply these two together, we would have 56 for a common denominator. To get 56 for a denominator, I had to multiply this times 7. That means I have to multiply the other side times 7 to not change its value, so I would have 14 over. Up here I had to multiply the denominator times 8. That means I have to multiply the 1 times 8, so I would have 856 is equal to 1/7. 1456 is equal to 2/8. Now, what I can do is add together the numerators. Now, that would give me 22 over 56. Now, I can add together the whole numbers. I would have 5 and 22 over 56. Now, this is improper. It can be reduced. To figure out what number to divide into it, just start out and say to yourself 2, 3, 5, 7, and so on, until you come up with a number that both sides are divisible by. Now, if you look at this, you see both sides are divisible by 2. It might turn out as you get into this, you might find out, well, you could have used 4. Well, if you use 2 twice, you're still going to end up in the same place. So you just break it on down. And in this case, I can divide 2 into both sides here. Go in there 11. 2 goes into 5 twice, 28 times. And see, I'll have 11 over 28. So my answer then would be 5 and 11 over 28. And that's as far down as I could reduce that.